Okay, notes 4.3 is all about changing the base in order to put it in base 10, so it's easy to put in the calculator. So the change of base formula is like this. So base b, we're going to put in base b of x over log base b of a. See how this goes on the bottom, and then this one goes to the top. Same thing for this. So we have a different base, but we want to change it. So our whole goal is to change it so it's in base 10, log base 10. So it can be anything. It can be log base 3 of x. And so the way we change it to base 10 is we put the x on top on the numerator and the base a on bottom on the denominator. So the same thing with log base a of x, we can change it to ln of x over ln of a. These are going to be equivalent. So we could use either one. So I'm going to show you both. And we are going to put it into the calculator when we get down to number 4. So this would be log base 10 of x, this goes on top, over log base 10 of 7.1. Or we could write this as the ln x over ln 7.1. So these are equivalent. You could use either one. Okay, the next one. Log base, let's use this one on the top. Log base 10 of x, which I don't even need to put the 10 there because it's understood 10 if there's no base, over log of 1/4. Or we could do ln x over ln 1/4. Okay, the next one. Log 4 over 5 goes on top. Log a goes on bottom. Or we could use the ln, the natural log. Okay, so the reason we are doing this is because in the calculator you can't always do log with a different base of 10. So scientific calculator is not like our TI-84 that we can do the alpha window to get to it. But if you just had a regular scientific calculator, you need to know how to do this. Okay, so let's go ahead and evaluate this. So we're going to write this as a log of 4 over log of 9. Or we can say ln 4 over ln 9. So we can put that in our calculator, which is what we want to do. So let me go to calculate 84. So alpha y equals, to get our fraction, and we're going to do log of 4 over log of 9. So 0.631. We're going to go to 3 decimal places. But remember, we can also do the ln, the natural log. So ln 4 over ln 9. They are the same thing. Equals 0.6301. So that's our solution. Okay, the next one, we are going to do log 0.045 over log 4. Or you can do ln, but remember they're the same thing. So we're not going to worry about going and doing both of them. We're just going to pick one and stick to it. So log of 0.045 over log 4. Negative 2.237. Negative 2.237. And next one, log 64 over log 1/8. Log 64 over log 1/8. -2. Okay. And let's see. Here are the properties. So these are going to be pretty important to know. So the product property is if I have log of A, U times V, I can break it up into log of A, base A, U, plus log of A, V. So see how I have the addition between them. Whenever it's multiplication, repeated addition. So the same thing here. We have ln uv equals ln u plus ln v. And then the quotient property, if I'm dividing u by v, I can do log base au minus log av. Same thing applies to our natural log. And then our power, if I have u to the power of n, I'm going to actually multiply that out front, put it out front. Okay, so let's go ahead and apply those on some examples. Okay, so 10x means I'm multiplying 10 times x, so this is going to be log 10 of 10 plus log 10 base 10 of x. Log base 10 of 10, remember they're the same, so we just get 1, because it'd be like 10 to the what power gives us 10? Well, it'd be 1. So plus, and I don't need the base of 10, I can just put it as log x. And that's completely simplified. Okay, this is division, so it's a quotient rule. So I'm going to subtract. So log base 10 of t minus log base 10 of 8. I could write this also as log t minus log 8. Okay, the next row we have an exponent of 4. So we're going to take that out front. So it's 4 log base 8 of x. And that is all I can do there. And I do need to make sure I keep that base of 8. Okay, let's go to the next one. ln square root of z. So using our rules of exponents, this really means z to the 1/2. When you have an exponent, we're going to put that out front. 1/2 ln z. Okay, we are going to do the rest of these in class. Okay, we're going to go on to the next part. Oh, also 10. Find the exact value of log without a calculator. Okay, so this is going back to the swirl method. So it equals x or equals some variable. Swirl. 3 raised to the x equals 9. Well, 3 squared equals 9. Or really, what I could have done is simplify 9 to be a base 3. And we know that that's 3 squared. So x equals 2. So log base 3 of 9 is 2. Okay, let's do the next one. So we're going to swirl. 4 to the x equals 16 to 3.4. So just like I did earlier, I changed 9 to a base of 3. I'm going to do the same thing here. 16 as a base of 4 is going to be 4 squared. And then I still have that 3.4 outside. So then I do 4 raised to the x equals 3.2 times, 2 times 3.4 is 6.8. So that means x equals 6.8. And we didn't even use that law that we just learned about. We just used the swirl method. Okay, let's go to the next one. Equals x. So we're going to swirl. So it's 2 raised to the x equals -4. Well, there's no way to get a -4 from 2 raised to some power. There's no way. There's no way. Can't ever happen. So this is a no solution. Okay, let's go to the next one. Log base 5 of 125 equals x. So swirl. 5 to the x equals 125. So we're going to change. We're going to change 125 as a 5 to some power. So 5 squared is 25. 25 times 5 is 125. So that's 5 to the 3rd power. So that means x equals 3. Okay, the next one. We have ln of e. Remember that simplifies out. That equals 1. Or it equals the number out front, actually. Or the number is the exponent. So this is 2 times 4. 2 times 4 is 8. So 8 is our solution there. Okay, we are going to do 6, 7, and 8 in class. So that is it for these notes.